All right, so I apologize I'm not here today, but I want to go ahead and just make this video. I'm going to make it kind of short and sweet and to the point. I'm trying not to stray off too much and go off on agents like I like to do. So it'll be short and to the point. Now, we're only covering one section. In this section, we've actually kind of already done before. So the challenge won't be finding necessarily the mean. It's going to be finding that standard deviation like we talked about yesterday. So in this section, we are talking about the mean and the standard deviation of what we call grouped data. So it can be tedious to compute the mean and standard deviation of a lot of data, meaning if I were to collect 100 data points and certain values occur over and over again, like this example of 60 football players, we're taking a look at how many weeks it took to recover from the injury, and then how many players took the same number of weeks. So there was only to take 1 week to recover from a shoulder injury, that happened 5 times. For 2 weeks to happen, that happened for 8 players. 12 players took 3 weeks, 19 took 4. So this is just raw data that was collected. And so when this surgeon or the doctor diagnoses a certain issue or repairs some sort of problem, they can say that you should expect to be out to 3 to 5 weeks, give or take a week, something like that. So we're trying to get those statistics down. Now, what I don't want to do is I do not want to go through Google Sheets and write all 60 of these values. That takes forever, especially if there was a problem. And normally on the test, just to make sure that people didn't do it, the test, I think the sample size was 545, something like that. So you obviously didn't want to click that all in. And it was when we were still using a calculator, so you had to type in each number individually. So there's definitely an advantage to using Google Sheets, or rather this formula. Now, the formula that we're going to be using is going to be exactly like what we did yesterday, but I'm going to be adding in times the frequency. So if we just got rid of this F, this is the formula for the standard deviation that I showed you how to do by hand. We're going to be forced to do that today. So it's kind of good that this is recorded, because you can go ahead and just follow the video and follow my steps. And then this is actually the last slide of the presentation. Then it gets into 3, 4 percentiles and box and whisker plots, but we'll do that on Monday. All right, so let's go ahead and get to our spreadsheet. So everything in yellow is what I am going to finish in this example. So the first thing I'm going to do is delete all this stuff, and we want to generate those. Okay, so this is the example that we just had. So first thing I want to talk about is what group data would look like if it was ungrouped. Well, I'm going to have 60 values. So I'm going to have 5 ones. So 1, 2, 3, 4, 5. Then I would have 8 twos, 1, 2, 3, 4, 5, 6, 7, 8. And then I would do the same thing with the 3s. And for the 3s, I had 12. And so we're going to keep going down. And we would have eventually 60 values. And then once we wrote all those values, then we could do equals average and equals standard deviation. So it is possible, but it's extremely tedious, especially if we had a bigger sample size that was in the hundreds or the thousands. And so here's how we're going to do it with Google Sheets. First of all, I want to acknowledge what the total is. The total is going to be 60. If you're not sure what it is, you can always do equals the sum and then just highlight the frequency. So I know that there were 60 football players in this example. Now to find the mean, now what we can think of this as is a weighted average problem. 1 has a weight of 5, 2 has a weight of 8, 3 has a weight of 12, 4 of 19, etc. So if these all have their weight, I'm going to do equals weighted average, or average.weighted, and I'm going to highlight the first column, comma, highlight the second. So according to the weighted average, I have an average recovery time of 3.82 weeks. Give or take how many? That's what we need to find out. So according to our formula, it's going to be every x value minus the mean squared times its frequency of it happening. Then I'm going to add those all up, divide it by n minus 1, and then take the square root of it. So I went ahead and wrote in there, oh yes, and of course, times the frequency. And so I'm going to go ahead and do an x value of 1. Oops, forgot that equal sign. Parenthesis, x value minus. Now again, I would like to just click on this mean, but unfortunately if I do that, it's going to also move down the cell. So this one you have to manually type in. Now I'm going to just do it for a couple places just to ensure the authenticity. You could have rounded it a little bit closer. And then I'm going to go ahead and square that and then multiply it by the frequency. So now me doing this cell, that has now set me up for my entire column. So I'm getting 39.668. I'm going to take this, drag this down, and now I have all these values. Now I'm going to go ahead and double check. So A3 minus 3.81, A4, A5, A6, A7. So this all looks pretty good. Now this is what I consider my new column. So now what I want to do is I want to take the square root of the sum of this new column and then divide it by either the entire population or by one less than my sample size. Now these are just 60 random football players. If we take at the wording in the problem, it just says a random sample of 60 football players. If it's the entire population, it wouldn't be a random sample because it's not very random if it's everyone. So that's how I know this is a random sample. And I'm going to go ahead and do equals the square root of the sum of this entire column close the parenthesis, and I'm going to divide by one less than my sample size. Now, a common mistake is that people look at this and say, all right, it's 7, but it's not because our total is 60 football players, so it would be 59. And so I am getting 1.69. Now, again, these are the number of weeks. And so it should be a relatively small number because if we're expecting 3-point weeks for a recovery, it should be like give or take a week or two other than that. So that's what we're saying, is that we're saying that within one deviation from the mean, you could expect between about, let's say 2.1 to about 5.5 weeks. So I would say between 2 and 6 weeks, I would say would be the recovery time. And if we relate that to Chebyshev's, then we'd have to go another deviation. We could say 75% of all people who get the injury can recover in these weeks. So this value here, I'm going to go ahead and just do equals, click, enter. So there's my standard deviation. So the expected time to recover is 3.8 weeks, give or take about 1.7 weeks. The other example I have here is if they give you a range, I can't use a range as an X value. Like I did over here, the weeks being 1 through 8, I can't use 0 to 2 as one value. So what we need to do is we need to take the midpoint of that range, and that will be the representation of that class. So between 0 and 2, if I find the midpoint, again, you just find the average. So 0 plus 2 is 2 divided by 2 is 1. 3 plus 5 is 8 divided by 2 is 4, etc. Now the frequencies I have here. And so this was, by the way, the amount of time you expect to wait in line. So you wait between 0 and 2 minutes. That happened 4 times, 3 to 5 minutes, 3. You can see the longest wait was between 9 and 14 minutes. So that should be somewhere where my average should be. And so my average is going to be equals the average. And again, it's average dot weighted. Hold up. There it goes. That's weird. I don't know why it's not doing it. Whatever. Just had to type it out. I don't know. Finicky. And so again, I'm going to highlight my midpoints, comma, highlight the frequencies, which are the weights, and I get that the average amount of time would be about 10.18 minutes, which again makes sense because 9 to 11 had the highest frequency, so I would expect it to be closer to that range than the 12 to 14 range. But again, with everything accounted for, you should expect to wait about 10.18 minutes. Now for the standard deviation, that one's going to be the more challenging one. I'm first going to start off with every x value minus the mean squared times its frequency. So equals the x value minus the mean of 10.18. Close that bracket. Should have opened it to begin with. Square it times the frequency, which is found over here. Highlight, there we go. All right, so now what I need to do is the square root of the sum of this column divided by my sample size. So I'm going to do n minus 1 again. Now, I don't know my sample size because it's all these numbers added up. So I'm going to go ahead and do that real quick, the sum of these frequencies. So there is a total of 50. And so now when I go through, I plan on putting that over here anyway. There we go. And so over here, I'm going to do the square root of the sum of this column. Close that bracket, and I'm going to divide it by 49. And so I'm getting that you should expect to wait about 10.18 minutes, give or take about 4.5 minutes. So that means that you should expect to wait in line about 6 to 14 minutes, which if we go back to our range, 6 to 14, that's going to cover 36 of our 50 points. So that's 72% of our data is covered in this range, and that's what one deviation from the mean represents. So your homework tonight is in the classroom. It's just 2 problems, and it's asking you to do stuff like this. So good luck. If you have any questions, send me an email. Do the best you can. Again, tomorrow, you're checking into the Zoom, and you can spend that time to get your projects done. All right, I will see you guys on Monday.